Hi guys, so I am going to go over the last two problems on the accumulation one homework. So it was the last two problems I wanted you to try on your own. All right, so number two, again, notice it is a number two, so that means it's a calculator problem. So before I did anything else, I would say go put this into y1, y2, and I like to label on my problem. Okay, that's my y1, that's my y2, so I don't accidentally get confused. So the rate at which people enter an amusement park is given by E of t. So enter, so this is my in. And then the rate that people leave is L, so this is out. So I got my in, I got my out. Both E of t and L of t are measured in people per hour. So again, they're rates. T is measured in hours after midnight. These functions are valid, so 9 a.m. to 23, which would be 11 at night. There are no people in the park at 9, right? So that means our initial value is 0. How many people have entered the park by 5 p.m. or t equals 17, round to the nearest whole number. So we're only being asked about entering, right? We don't care about the leaving. So it's really the focus is E of t. So the integral, right? Because we're finding how many people. When you integrate a rate, you get a total amount. And it opens at 9, and at 5 it's 17. And that's literally all you need to write. Put that in your calculator, and you should get 6004. You are done. There is nothing else you need to do. Okay? Not a lot of work to show. All right, B. The price of admission is $15 until 5 p.m. After 5 p.m., the price of admission to the park is $11. This must be an old problem because that's super cheap. How many dollars are collected from admissions to the park on the given day? So from 0 to 5, so from 9 to 5, right? 9 p.m., 9 a.m. to 5 p.m., we've got $15 times the total number of people that enter the park. 6004, which we found. Now, if you found 6004 wrong, you will still get points. And then 11 times, we need to figure out how many people entered the park from 5 to 11. So we're going to do the integral from 5 to 11 of, not 11, 23. Eraser. No, it's not 5, it's 17. So let's, military time, guys. So 17 to 23 of E of t dt. Again, just put that in the calculator. Do not try to do that. Well, you can't do it by hand, but don't try. And I got 1271. So 1271. Multiply all that out, and I got 104,041. And we are done. All right. Part C. C is the hard part. D is not always the most difficult problem. All right, so again, this is my y1, this is my y2, this is my in, this is my out. I really like labeling. All right, C. Let h of t equal the integral from 9 to t, e of x minus L of x. The value h of 17 to the nearest whole number is 3725. Find the value of h prime of 17 and explain the meaning of h of 17. All right, so h of t is the integral from 9 to t, e of x minus L of x dx, which means that h prime of t, right, the derivative is the inverse of the integral. So you just substitute in e of t minus L of t. So then we want to find h prime of 17, e of 17 minus L of 17. Now, in the calculator, what I'm going to do is y1 of 17 minus y2 of 17. I'm writing this just because I can't show you the calculator using this program I'm using to make my videos. So don't do that. Don't actually write that on your AP test. Just do the subtraction. So I'm writing y1 minus y2 of 17, and I got negative 380. So then it wants to know, what is the meaning of h of 17 and h prime of 17 in the context of the amusement park? All right, so what does h of 17 mean? Well, h, if we're integrating the rate, right? These are rates. The rate of people entering minus the rate of people leaving. So h of 17 is how many people are actually in the park at 5 o'clock, 17, right? So h of 17 is the number of people in the park at 5 p.m. H prime of 17, so this is a rate. The rate of people entering minus the rate of people leaving. So this represents the change in people entering and leaving the park. So at 5 p.m., negative 380, well, you don't even have to make it, people per hour are leaving the park. So more people are leaving than coming in. That's why it's negative. So you can make it negative, or I'm instead of making it negative, I just use the word leaving. Okay. All right, and D. Oh, I'm gonna run out of space. All right. At what time does the model predict the number of people in the park is a maximum? All right, notice this keeps coming up in these problems. Maximum. Number of people in the park is h of t. How do you maximize h of t? We take the derivative and we set it equal to 0. So when is e of t? We found this up here, right there. H prime of t is e of t minus L of t. So where is e of t minus L of t equal to 0? So e of t equals L of t. So we're using our calculator, and watch the video on using the calculator because I use this, I use the graph to do this. So when I solved this, I got t equals 15.795. So then, again, you're supposed to really check your it wants maximum, right? So then we're going to figure out what is h of 9, what is h of 15.795, and what is h of 23. So go through and find those numbers to show that this really is the maximum. Okay, and that's it. Let's look at the answer key. So A was 6004. So notice we get our point for the 9 to 17, a point for our limits, a point for the integrand, and a point for the answer. Letter B, notice it's only the setup. So as long as you're multiplying the correct stuff together, like I had that, I did it this way, I did it like B. As long as you're setting it up, that's all that matters. They don't even care that you got the right answer, which is interesting. All right, h prime of 17, which we got. The meaning of h of 17, the number of people at the park. The number of people in the park was decreasing at a rate of approximately 380 people at t equals 17. Now notice it says no reference to t equals 17, you lose a point. So you have to either say t equals 17 or I said 5 p.m. Those are both correct. And then setting the derivative equal to 0 and finding your answer. So I guess they don't give you the points for showing that. This is an old problem though. This is from 2002. I would definitely check your endpoints because that's important. That might not actually be a max or min. All right, second problem. A tank contains 125 gallons of heating oil at time t equals 0. So that is our initial, right? So that's my initial. We have 0 to 12. Let's see. Heating oil is pumped into, so this is our in, removed, this is our out. How many gallons of heating oil are pumped into the tank from 0 to 12? So 0 to 12. Notice how easy A usually is. Pumped into, so H of T. You don't even have to write the function. I never write the function because I don't want to accidentally write it wrong. Equals, I got 70.571 when I did it. How many gallons? And we're done. Remember 3 decimals, guys. Put gallons. Is the level of heating oil in the tank rising or falling at T equals 6 hours? So we need to figure out what's happening at 6. So I found H of 6, and I got 5.395. And then R of 6, the removed, was 8.319. So I said falling since R of 6 is greater than H of 6. That's it. Make sure you give a reason. That's definitely going to be part of the answer. All right, C. How many gallons of heating oil are in the tank at 12 hours? This is such a straightforward question, guys. Like, I want you to get really good at these. How many gallons? So that's a total amount. We're talking integral. At T equals 12, so we're going from 0 to 12, right? And it's not how many have entered, it's the total. So it's the in minus the out, H of T minus R of T. Notice I left space. What has to go out front? Don't forget about your initial. That's huge. So 125 plus you really don't even have to do anything here. You just can put the answer. You don't have to show any other work other than this, so our laziness comes out. We can do it just 122.026. We're done. All right, that's it. You don't have to show any other work. All right, so in this one is the more difficult one. So in, out, initial. All right. At what time is the volume of heating oil in the tank the least? So the least, so that's a minimum. I hope after only 4 problems you are noticing the repetition. We're finding max and min, we're finding total amounts. So I like to make a function for this. So my total, the total amount of heating oil equals the integral from 0 to T, H of X minus R of X. All right. So to find the total amount, it's going to be the in minus the out, and then plus the initial, right? We can do 125 plus. So then to find the least, that's a minimum. So T prime equals, the derivative of 125 goes away, H of T minus R of T. Set that equal to 0. So when is H of T equal to R of T? Again, I'm going to show this in the video. I'm using my calculator. I got 2 answers. There are 2 places where these are equal. T equals 4.790 and T equals 11.318. So then to show which one's the least, we're going to plug into my total formula. So T of 4.790 is 125 plus the integral H of X minus E of X, R of X, sorry. And what do I get for my answer? So I end up getting 149 1.408. 149. And then I do the same thing, but with the 11.318. And that gives me 125 plus negative 4.262. So it's around 121. T of 0 is 125. So far this is the least. And then you really got to check T of 12. And T of 12 ends up being bigger than that. So let's see, what's the question? At what time? So T equals 11.318 is your answer, right? But make sure you show the math to make it clear that you know you're supposed to check. All right, so here are our answers. So notice for A, you don't really need to put a lot of work in there. I keep saying number. B, answer with reason. So they had H of 6 minus R of 6. I found them separately and just said that R is bigger. Both of those are correct. Letter C, we have our initial plus the integral, super straightforward. So in this one, notice they do say the absolute minimum occurs at a critical point or an endpoint. So they found our two critical numbers. And then they kind of describe it. I'll talk about this more in the calculator part. The volume increases until 4.79, then decreases, then increases. So the absolute minimum will be at 0 or 11, and then you plug in and you get that it really is at the 11.318. All right, so I'll get more into the description on the calculator, but those are your two homework problems. If you have any questions, please reach out. So next you are going to do some more accumulation problems that I will be posting on the classroom. Have a great day, guys.